Yeah.
So, welcome to this video. We are going to be talking about operator D technique. The basic concept of operator D is transforming the meaning of this D. Our D operator is the dx. So, whenever you see something like dy, it means the y dx. This y is the one that was separated out. So, when you see d squared, it means d squared dx squared. So, if I put y there, it means d squared y dx squared. So, that's the second order differential equation. So, we use this to simplify any question like this. So, for example, now for the first one, I can write the first one as this is dy dx. So let me make sure that my writing is big. So I can write this as the first question as dy, or yes, dy minus 2y equals to e raised to power 4x. So if I write it, I can factor y out of this and say d minus 2 of y equals to e raised to power 4x. So this d is just, it functions the same way our x and y functions. It functions the same way, almost the same way as x or y functions. So I can even say the squared equals to d times d. I can say 2d equals to d plus d. If you get what I'm saying. So we can just continue it just like that and that. So that's the basic idea behind D operators. D operators mean differential operators. Now, for the first one, for these few questions, we are going to be solving each of them using the operator D technique. The operator D technique for solving all these ones is called the inverse operator method. So, what the inverse operator method is about is look at the first question. We have D minus 2y equals to e raised to power 4x. So, we are going to turn this into inverse. What we are looking for is our y. So, I can call this my yp, right? So, it means my yp equals to e raised to power 4x over d minus 2. So it's now in the inverse. So this is what we call it the inverse operator method. So we are going to be using this method to solve each and every one of these, to evaluate each and every one of them. So in our evaluation, we don't really need, if they ask us to evaluate any question like this using the operator D technique, we don't need the homogeneous part, we don't need the complementary part. YC. We don't need it. But if they ask us to find the general solution, we have to find it. Y equals to YC plus YP. And since we have talked at length about finding how to find the complementary part of any equation like this, we are going to skip it so as to make this video short enough because we have a lot to cover in this video. So for the first one, let's evaluate the first one using operator D technique. So we have g minus 2y equals to e raised to power 4x. Now, we are going to write this as y equals to e raised to power 4x over d minus 2. So, there are two methods that we can use to evaluate this. There are two methods. The first method is that we use this table. I'm going to write the table here. I'm going to continue updating the table as we continue. So, let's say we have a function like e raised to power mx over d. Don't let me use mx, let me say p. E raised to power px over d plus m. Let's say we have something like this, e raised to power px over d plus m. The way we evaluate it, the first way is by saying this equals to e raised to power, instead of writing plus m, we write minus mx first, the integral of e raised to power mx. Don't forget this. This is the first two things you need to do. E raised to power mx, integral of e raised to power mx. From plus to minus, then you just write your plus. You can actually use anything here. It can be anything. It can be any r of x. It can be any function. Then times your r of x. It can be any function. It can be an exponential function. It can be x squared. It can be e raised to power x squared. It can be anything. It can be anything. So that's the first thing we need to know. So evaluating this one using this format, we are going to now have something like e raised to power negative of minus 2 is 2. E raised to power 2x integral of e raised to power minus 2x. So can you see the format it went along with? Dot, what is on top? E raised to power 4x dx. So this is going to give us something like y, our particular y equals to e raised to power 2x integral of e raised to power 2x minus 4x minus 2x gives us 2x dx. So this gives us something like e raised to power 2x dot, this will give us e raised to power 2x over 2. So this is equal to e raised to power 4x over 2, right? So yp equals to e raised to power 4x over 2. So we have successfully evaluated this. We have successfully evaluated this, and this is our particular y. We can solve for our what's it called complementary y analysis to it, but we don't need that. So evaluating number one, we have gotten this using the first method, using this, the first method. So the second method we are going to use to solve the same number one. The second method we are going to use to solve the same number one is by using this transformation. In inverse operator method, we have a lot of transformations that we have to know. So whenever we have something like e raised to power px over, this one functions basically for e raised to power px. E raised to power px over something like this. So we transform it into something like, let d equals to p. Do you understand what I just said? Let d equals to p. So we are now going to have something like this. This is number one again. We are going to have something like y equals to e raised to power 4x over d minus 2, right? It's over d minus 2. So let d equals to 4. Let d equals to p. So we are going to have something like e raised to power 4x over d is 4. 4 minus 2, which equals to e raised to power 4x over 2. We are done with it. So it's as simple as that. Let d equals to p. So this is the second method we can use to solve this is the second operator technique we can use to solve questions like this. So after this one, let's go to the second question. For the second question, we have, this is d square y, second derivative, minus dy minus 2y minus 2y equals to 3e minus 2x. So we can factor y out of this and say d squared minus d minus 2 of y equals to 3e minus 2x. So we can now have something like our y particular equals to 3e minus 2x over d squared minus d minus 2. So to solve this using the second one, we are going to say let d equals to p. So we are going to have something like 3e minus 2x over, now d equals to p, our p is minus 2. Minus 2 squared minus 2 minus 2. This gives us 3e minus 2x over minus 2 squared is 4. 4 plus 2 minus 2, which cancels out. So we have our y particular equals to what? 3 over 4 e raised to power minus 2x. And this is our particular solution using this second method. So we are going to use the first method as well. So using the first method, we got 3 over 4 e raised to power minus 2x. So the first method, there is a, since this is a first method, our yp equals to e raised to power 3e minus 2x over d squared minus d minus 2. So we can factorize this, minus 2 and 1. We can factorize this and say we have 3e minus 2x over d minus 2, d plus 1. Am I correct on that? Yes. Yes, we can factorize this and say d minus 2d plus 1. We can factorize this and say d squared minus 2d plus, yes, exactly. So solving this using the first method, we can now see we have 1 over d minus 2, 3e minus 2x over d plus 1. We are still talking about the same thing. So let's solve the one inside using the first method. Using the first method, we have 1 over d minus 2 dot, or let me bracket it. So we are going to have e raised to power minus, this is 1, minus x integral of e raised to power minus, so that's plus x, e raised to power minus x, e raised to power plus x, dot 3e minus 2x dx. So I can bring this out and say 1 over d minus 2, integral of 3 will come out, 3e minus x, integral of e raised to power x minus, so this is minus x dx, if you get what I'm saying. So let's integrate this. We have 1 over 2, 1 over d minus 2 into bracket 3e minus x. If we integrate this, we get minus e minus x, we are multiplying. So this is 1 over d minus 2 into bracket minus 3e minus 3e minus 2x minus 2x. So we are going to work this out again using the exact same method.
Wonderful.
So we are going to work this out again using the exact same method and say we have something like um e raised power, this is minus, so we turn to plus 2x integral of e minus 2x dot what we have here minus 3. I can bring out minus 3. Minus 3 integral of e raised power minus 2x. So this will transform into something like minus 3 e raised power 2x integral of e raised power minus 4x dx. Minus 2x minus 2x is minus 4x. So if we do this, we have minus 3 e raised power 2x dot, if we integrate this, we have minus is coming down, minus e minus 4x over minus 4 over 4, sorry, since minus is coming down, okay, minus 4, right? Yes. So this is cancelling this. So we have 3 over 4 e raised power 2x dot e raised power minus 4x, which is e raised power 3 over 4 e raised power minus 2x. And that's our y particular, our solution to this using both operator D techniques. Then another thing we can do using this same number 1, this same number 2, sorry. If you look at this, you see this is the product. So we can basically split this using partial fraction. We can use partial fraction to solve this by saying a over d minus 2 plus b over d plus 1, everything 3e minus 2x. I'm not going to finish this for the sake of time. Oh, let me finish it.
No time.
Let me finish it. So solving this, we are going to have something like a into bracket d plus 1 plus b into bracket d minus 2 must be equal to, let's say must be equal to 1. Yes, must be equal to 1 since I've factorized this out. So I have a d plus a plus bd minus 2b equals to 1. So comparing the constant terms, comparing the d terms, we have a d plus bd, there's no d here, equals to 0. A minus 2b equals to 1. So it means a equals to minus b. So we have minus b minus 2b equals to 1, which means minus 3b equals to 1, b equals to minus 1 over 3, and a equals to 1 over 3 automatically. It is negative b. So a equals to 1 over 3. So this will now transform into something like a is minus 1 over, a is 1 over 3, 1 over 3 over d minus 2 plus b is minus 1 over 3, so I can write this as minus 1 over 3 over d plus 1. Everything 3e minus 2x. So I can now simplify this one. So I can now simplify this and write it as, if I bring it inside, 1 over 3 will cancel out both of them. So we are going to have something like e minus 2x over d minus 2 minus e minus 2x over d plus 1, which you can solve using the first or the second. So solving this using the second one, we are going to have, or let's use the first one. Let's use the first one, which is easier. Let's use this one, which is easier. D equals to P, let D equals to P. D is minus 2, so we are going to have e minus 2x over minus 2 minus 2 minus e minus 2x over minus 2 plus 1. So we have e minus 2x over minus 4 minus e minus 2x over minus 1, which is just plus e minus 2x. So when we add this together, what are we going to get? Since this is 1 over 4, so we have, this is going to give us e minus 2x into bracket 1 minus 1 over 4, which is 3 over 4. So we have 3 over 4 e minus 2x, which has been the answer we've been getting since. So that's how to solve using operator D techniques for question 1 and question 2. It's as easy as that. So going to question number 3. we are evaluating each of them, please. We are evaluating. I'm not looking for the complementary solution. You can do that on your own. Y minus 2, you can just write out the auxiliary equation of this. This is r minus 2, right? So r equals to 2 is whatever. So, or, wait, for this, r minus 2 equals to 0. R equals to 2, which means our y equals to e raised to power rx, which means equals to e raised to power 2x. Since we have only one y, our y1 equals to c1 e raised to power 2x. So we have our y2 to be equal to c2 x multiplied by x e raised to power 2x. So I've done videos on this. You can check it out on how to find your how to find the solutions of your homogeneous part, the complementary solution of your homogeneous part. You can check out the videos that we've done on that. So going to question number 3, we have writing this one in D, minus 3 dy plus 2y equals to e raised to power 5x. So factorizing y out, we have d squared minus 3d plus 2, everything into bracket, y equals to e raised to power 5x. So we divide everything through. So we have our yp, our particular y, equals to e raised to power 5x over d squared minus 3d plus 2. So using the second method first, which is the easier method, we are going to get our p equals to 5, right? So our d equals to our p, which equals to e raised to power 5x over, since d is 5, so we have 5 times 5, which is 25, minus 5 times 3, which is 15, plus 2. So this gives us e raised to power 5x over 10 plus 2, 12, and this is our y particular. So that's the solution for y. Don't forget, this is y particular. You can first find your yc. So our general solution will now be, if they say find the general solution, it's now be y equals to yc plus yp. This one is yp. So you can find your yc on your own. So
My 3.
question number 4 now. We are done with question number 3 and we got our yp to be equal to e raised to power 5x over 12. So for question number 4, we have d cube plus d cube y plus d square y plus 2 dy minus y equals to cos 2x. Now this one works with an entirely different what's it called? D cube plus d squared plus 2d minus 1 everything y equals to cos 2x. So it means my y particular equals to cos 2x over d cube plus d squared plus 2d minus 1, right? So there's another formula we use for cos and sine. Whenever we have cos px plus q over, let's say, a function of d. Now don't forget, this is a function of d. This one is also we can also write it, instead of writing d plus m, I can write it as a function of d. A function of d, a phi of d means something like, let's say we have d squared plus 3d, like something like this is a function of d. It's a function in terms of differential. It's a function in terms of differential. Please don't mix what I just said. So we are going to transform this into something like this. What we are going to use here, the transformation we are going to use here is d squared equals to minus p squared. This is transformation we are going to use here. D squared equals to minus p squared. So we have cos 2x, which means our p is 2. So in this question, our p equals to 2. So we are using our d squared equals to minus p squared is 2, which means this is p squared is 4, sorry. So d squared equals to minus 4. We are going to substitute minus 4 anywhere we see d squared in this question. So we are going to have something like yp equals to cos 2x over, now don't forget this is d cube, which means I can write it as d squared. D times d squared is d cube plus d squared plus 2d minus 1, which equals to cos 2x over, now the transformation is going to come in now. D squared, anywhere you see d squared, make sure you write minus 4. So we have minus 4d plus, now this d squared, which is minus 4 plus 2d minus 1. So this is going to give us something like cos 2x over minus 4 plus 2. We have minus 2d minus 4 minus 1 minus 5. So now, since we have something like this here, what we are going to do next is to multiply both the numerator and denominator by the conjugate of this. Multiply it by minus 2d plus 5 over minus 2d plus 5. You get what I just did here? So after we multiply it by the conjugate, we are going to get something like this. Okay. So we are going to get something like this. Minus 2d plus 5 into bracket cos 2x. I multiplied it up by this over, if you multiply this one by this one, we are going to have 4d squared minus times minus is plus 4d squared minus 10d plus 10d minus 25. Now this cancels out, so we don't need it. It cancels out, so we don't need it. So minus 25 just stays. So we are going to do this, opening this bracket, we are going to get something like minus 2d cos 2x plus 5 cos 2x all over 4d squared. I can now evaluate this one. D squared equals to minus 4. My d squared equals to minus 4. So this is minus 16. 4, yes, minus 16 minus 25, which gives me minus 41. Now look at this. Don't forget, dy means you should differentiate y. Is dy dx, right? Differentiate y. So it means minus 2d cos x means d cos x cos 2x means differentiate cos 2x. So we are going to get something like, cos 2x. If cos 2x, if you differentiate it, minus is going to come out. So it's going to turn this one to plus. So we'll have 2 sine 2x. 2 is coming out. So this one is going to turn to 4. So we have 4 sine 2x plus 5 cos 2x, everything over minus 41. And this will be our y particular. This is the final answer for number 4. For question number 4. This is our final answer. So whenever we say cos, okay, it works for sine too. Only cos and sine. Sine px over q plus q, over phi of d. You use this transformation to d squared equals to minus p squared. Let d squared equals to minus p squared. So this is the final solution for question number 4. So going to the last question, question number 5. And don't forget, please, we are only looking for the particular solution. We are only evaluating this, and this is giving us our particular solution, not our general solution. So for question number 5, we are going to have something like d cube y plus dy equals to e minus 2x cos 2x. So we have d cube plus d into bracket y equals to e minus 2x cos 2x. So dividing through, we have our y particular to be what? E minus 2x cos 2x over d cube plus d. Now this is another classic transformation. So whenever we have something like this brings us to our fourth, what's it called? Whenever we have a function like this, e raised to power, let's say px, where p is minus 2 here, e raised to power px, and another function, f of x, and another function over the phi of d. So the first thing you are going to do is to transform this in terms of px and remove px away. You don't need it. It's going to become something like a constant. So we are going to transform into something like e raised to power px 1 over. So this one, instead of writing phi of d, instead of working with d, we are going to be working with a function of, you are going to transform d to d plus p. This p, you transform it into d plus p, then you write your f of x, then you solve this one normally. You solve this one the normal way that we solve it. Now let's use this one to do the example. So here our p equals to what? Equals to minus 2. This one e raised to power px. So it means our y particular equals to e minus 2x cos 2x over, instead of writing d, we write d plus p. D plus p q plus, instead of writing d, we write d plus p. Now our p is what? Minus 2. So I can replace this plus p with minus 2. Minus 2, minus 2. So opening this, we have something like yp equals to e raised to power minus 2x cos 2x over opening this, we have d minus 2 into bracket, opening this one squared, we have d squared minus 2d minus 2d minus 4d plus 2
Plus 4.
plus
Plus 4.
plus d minus 2.
Plus
Oh, sorry, plus 4 plus d minus 2. Now opening this one, we have it as e minus 2x cos 2x over d cube minus 4d squared plus 4d minus 2d squared plus 8d minus 8 plus 8d minus 8, yes, plus d minus 2. This d minus 2 that is there already. So simplifying this, we have something like, so simplifying this, we are going to have something like y of p equals to e raised to power px, which is now something that is now going to be obsolete. It's now going to look like a constant. E minus 2x, then cos 2x over we have d cube is standing alone, d cube minus 4d squared minus 2d squared gives us minus 6d squared, and plus 4d plus 8d gives us plus, okay, plus another one here. So we have plus 13d minus 8 minus 2, that gives us minus 10. So we are now going to solve this one normally. So we are going to use this cos px plus q, where our p is now 2. So we are going to do d squared equals to minus p squared. Our p is now 2, is equal to minus 4. P squared is 2, and p squared is 4, sorry. So that's minus 4. So we have e minus 2x cos 2x over, this is d squared, d squared, if you remember, if you understand what I just said. So this is now d times d squared. So d squared is what? Minus 4. So I have minus 4d here. Minus 4d minus 6 into bracket minus 4. D squared is minus 4 plus 13d minus 10. So what I have here is now something I can translate as e minus 2x cos 2x over minus 4d plus 24 plus 10 plus 24 minus 10, that's plus 14 plus 13d plus minus this one. 13d minus 4d is 9d. So we have 9d plus 14. So what do? We multiply both numerator and denominator by the conjugate. 9d minus 14 over 9d minus 14. So this is going to yield something like e raised to power minus 2x. 9 differential of this is minus 2 sine 2x minus 2 sine 2x times 9. This gives minus 18. This multiplied by this gives us minus 18 sine 2x minus 14 cos 2x. Everything over 9 times 9 is 81d squared minus 9, and 14 plus 14 gives something else. So this gives us minus 14 squared. 14 times 14 is
196.
196. 196. Alright, so this square, don't forget what this square is. This square is minus 4. So we have minus 81 times 4 is 324. So we have minus this. Yes. So our final answer is going to become e minus 2x minus 18 sine 2x minus 14 cos 2x over minus this plus this. This is going to give us 400 and
520.
520.
Yes.
Or yes, that's 520 minus 520. So minus can easily cancel out the minus on top here. So our answer is what? E raised to power minus 2x into bracket 18 sine 2x plus 14 cos 2x, everything over 520. And these are y particular. And we are done with operator D technique. So this is everything you need to know in operator D. Probably everything you need to know. Yeah. Yeah. So whenever you're asked to evaluate something like this, any question like this using operator D, if you're asked to find the general solution, make sure you find your complementary solution first. Complementary solution means make this zero, make it an homogeneous equation, then find your y particular one, your complementary yc. If you have to find the general solution, but in this one, we just evaluated each of them, finding their particular solution, and we were able to find everything. So make sure you like this video, make sure you share, make sure you subscribe. Thank you. See you in the next video.